All right, well, this is section 10.3. So if you'd set up your notes, our third section in chapter 10, dealing with exponents, and we're going to deal with things called roots, but not today. We don't have to worry about the roots today. We're just dealing with negative exponents today and a zero exponent. What do you do if you have a zero exponent or a negative exponent? What in the heck does that even mean, right? So we're going to try to figure those things out. Well, here's what I want you to do. If you haven't put the video on pause yet and set up all your stuff here, put this table down, and I want you to come down here first to 1. So what does 3 to the first power mean? Well, that just means you got one factor of 3, right? That's what that 1 is telling us. We got one factor of 3. And then factor means like a number multiplied by something else. Now you might say, well, if there's only 1 3 here, what's it multiplied by? You could always think about like a 1 out front. So there's a 1 factor and a 3 factor, right? So there's 1 3 factor. Here we've got like 1 times 3 to the second factor. I know that seems a little weird, like what are you putting a 1 there for, Nelson? Well, I think I'll make it clear in just a second. Okay, so how many factors of 3 do we have now? Well, we got 3 times 3. Notice I didn't put the little 1 out front. It's kind of unnecessary, right? At this example right here, it's not necessary. So we end up with 9, right? So we got 2 factors of 3. Well, what does this mean? Well, we got 3 factors of 3. 3 times 3 times 3. We got 27, right? What does this mean? We got 4 factors of 3. 1, 2, 3, 4. That's 81. Now, here's what I want you to notice. To go from 3 to the first to 3 to the second, we have an additional factor of 3, right? So we're multiplying by 3. To go from 3 to the second to 3 to the third, we've got another factor. Let me draw a little arrow between the 9 and the 27. We're multiplying by 3 again. To go from 27 to 81, we're multiplying by 3. So to go the other direction, to go from 1 to 0, okay, so we were going from 1 to 2, 2 to 3, 3 to 4. What if we're going to go from 1 to 0 now? Well, now we need to divide by 3 because we're going the other direction. So if I divide by 3, I'm down to 1. Now wait a minute, why would that make sense? Well, I have 1 times 3 to the 0. Well, how many factors of 3 is this saying I have? I have no factors of 3. That's what 0 means. You have no factors of that thing, of that base. So what do I have left? I just have the 1 that's sitting out front. So we got 1 right there. Another way to think about it is, like I just said, you divide by 3. So now to get down to a negative exponent, here we're trying to understand what a negative exponent is, right? To get down to a negative exponent, well, I need to divide by 3 again. So what is 1 divided by 3? It's 1/3, right? So that is what 3 to the negative 1 is equal to. It's equal to 1/3. It's equal to 1 over 3. So that negative 1 says, hey, you know what? That base, that 3, really belongs in the denominator. So you could think about, like, if I put it in the denominator, I can change the exponent to a positive 1. So now that's where it belongs. So we've got 1 factor of 3 in the denominator, right? Let's go for 3 to the negative 2. What do you think that would mean? Just pause the video for a second, and I want you to put down your answer right here. All right, I hope you did this. I hope you said, well, that's the same as 1 over 3 squared, and 3 squared is 9, so I get 1 over 9, right? Let's go for one more. What's 3 to the negative 3? 3 to the negative 3 would be 1 over 3 cubed, which means we've got 1 over 27, right? So let's go back here and summarize what we just figured out. Anything to the 0 power is equal to 1. That's what we were just saying right here, okay? We were saying, hey, you know what you're going to get is you have no factors of that base. You still can think about like a 1 out front, 1 times, anything to the 0 power here. So that means we have no factors of that base, so we just have the 1 that's out front, okay? A negative exponent, what does that mean? That means that if you have a base to a negative exponent, it really means that base belongs in the denominator. Okay. Now, let's look at another situation. Sometimes they'll try to confuse us and they'll put down something like this: 1 over. I'm going to use a different letter. Let's say we use the letter G. G to the negative. I don't want to use the C up there. So let's use to the negative F. Okay. So what does that mean? It means I've got G to the positive F. It's like we've moved the G up to the numerator. If it's more obvious to you, you can put a 1 down the denominator. I'm taking this guy, I'm moving it up to the numerator. and I'm making the exponent a positive. That's what a negative exponent is really telling us. It belongs in the other place. This base to that exponent really belongs up in the numerator. Or if it's in the numerator right now, like you could think about it like this, then it really belongs in the denominator. So let's look at some examples. In this example, this monster here is raised to the 0 power. Oh, I love that. Boom. It means there are none of these factors. That's what that 0 on the outside is saying. There are none of these factors. They're just trying to test us if we know what anything to the 0 is equal to. It's equal to 1. All right? So real quick, pause the video. Go try problem number 4. They didn't put it in order. I wish they would have put this one as number 1. Go try problem number 4. All right, I hope you got it. Boom. It's equal to 1. Anything to the 0 power is equal to 1, right? All right, well, let's look at this kind of more complicated situation, and I'll zoom in on it since it's kind of written small down here. Well, I see something to the 0 power right there, so that means there are no b's in this expression. So if we're going to take this like one step at a time, I'd write a to the 4th all over a squared because the b has gone to 1. This all has become equal to 1. And so now what do we got? We got 2 a's in the denominator and 4 a's multiplied together in the numerator, and now we're back to that quotient rule where you're going to take 4 minus 2. When you're doing division, you're going to subtract the exponents, and so we end up with a squared. If you get confused, you can always think about, well, I've got 4 a's up in the numerator all multiplied together, and I got 2 a's down in the denominator multiplied together. Won't 2 of these a's divide out with 2 of the a's in the denominator, right? And we get a 1 from all that division right there, and we're left with a squared, okay? So anytime you see a factor with 0 on it, it's equal to 1, right? Let's go back here and let's look at the negative exponent example. If you have something to the negative exponent, it really means it belongs in the denominator. So that b to the 4th is going to the denominator. That c to the negative 2 is going to the numerator. So I end up with a cubed c squared all over b to the 4th. The negative is just saying switch the location of that factor. It belongs in the denominator. This factor here belongs in the numerator, right? So I want you to go pause the video, try problem number 1 over there on McGraw-Hill's assignment today. Good. Hey, I hope you got it right. Here's what needs to happen. You need to move the n to the negative 7, in my opinion. You move it down to the denominator. You move the n squared up to the, whoa, the n squared is a positive. Ah, okay, so hold on one sec here. Here's what I'm gonna do. I'm gonna go r to the 6th. That's up in the numerator still. I got r to the 4th in the denominator, and now I've got an n to the 7th in the denominator, and I've got an n squared in the denominator. So let's see what happens here. Well, when you're doing division, we subtract the exponents. We get r squared up in the numerator. That's what's left in the numerator. In the denominator, I got n to the 9th power. Now, sometimes the example does it a little differently. If you look at example 3 in your textbook, they might do something like this. They might just say, you know what we're going to do is we're going to simplify this division right here. Okay, so here's option 2 to solve this problem if that option 1 didn't make sense. When you're doing division, you subtract the exponents. So I get a negative 7 minus 2, which is going to give me a negative 9, right? So now what do we have? We have r to the 6th, n to the negative 9, all over r to the 4th. I guess I didn't deal with the r's yet. And so what do we need to do here? Well, we'll deal with the r's. We get r squared, and then n to the negative 9. But they don't want you to leave it with a negative exponent. So what we're supposed to do is say, oh, you know what? That n to the negative 9, that really belongs in the denominator. So let's move it back down to the denominator. So I get r squared all over n to the 9th power. See, you could just follow the properties that we've learned already in section 1 and 2 and do the subtraction, you know, for the negative 7 minus 2. That's what I'm saying right there. That's where that negative 9 comes from. But I kind of like just saying, you know what, I recognize this. It belongs in the denominator. So I change it. I move it down to the denominator. I change it to a positive 7. So I get n to the positive 7. All right. Oh, man, I hope I'm making this clear. If I have, just pause the video, stop watching, go do some more homework. I'm going to do example 3 and see if I can help some people out with this. okay? So, well, I see 3 over negative 36. Let's just talk about that for a second. 3 over negative 36. But I'm going to write negative 36 as 3 times negative 12. Okay, 3 times negative 12 is negative 36, right? Now I see that the 3's are going to divide to 1. So I'm going to make a little note of that. Okay, I'm going to make a little 1 up here. So 3 divided by 3 is 1, right? Now what do we got? We've got g to the negative 3. My opinion is move it to the denominator. So we've now got a g to the third, but we have another factor of g to the third right there. So that g to the negative 3 is that one. This second one is the one that was already down. Oh shoot, I put a negative on that. Why did I do that? It's just a positive 3 down there, right? And then we've got what? We've got an h squared. Ooh, how about we try to do this little simplification right here? So this is an invisible 1 on that h. So we got 2 minus 1 is 1. So we've got an h still in the numerator, and then we've got a j to the negative 4, which means, you know what? That j really belongs up in the numerator. So I'm going to put a j to the fourth up in the numerator, make it a positive 4. Okay, so I move that j to the negative 4 up to the numerator. Now we'd want to simplify a little bit, you know, and get rid of these little slash out deals here. You know, we don't want that there. And so we got hj to the fourth power all over g. Oh wait, we got a negative 12 down there. Negative 12 g to the sixth power, right? When you're multiplying, you add their exponents together. So I don't know if anybody's noticed this or if this bothers anybody. It says make sure, you know, assume that the denominator is not equal to 0. Well, if the denominator was equal to 0, like this original denominator was 0, then we can't divide by 0. This would be an undefined expression. So they keep saying that over and over again, but it's pretty easy for us to ignore it. I mean, of course it doesn't equal 0. Otherwise, they wouldn't have given us this expression. So I hope I'm making all that clear. Thanks for watching my video. Good luck on the homework.